Welcome, welcome. It is Friday, March 28th, and this is our instruction for today. If you notice, you picked up 7.3, radical operations, adding and subtracting, etc. Now, we've done a little bit of this before, and you have done a little of this before, but let me show you the biggest problem we're going to have today. This is the biggest problem. We can add and subtract radicals as long as they're a perfect match. Let me show you. See, we are allowed to add something like 6 radical 2 plus 8 radical 2. We can add that. That would be 14 radical 2. Okay? Now notice the radicals were a perfect match. A perfect match. Well, what do you think is going to go wrong here? Yes, a lot of students are going to say that radical 2 plus radical 2 is radical 4. You can't add or subtract what's under the radical when you're adding or subtracting like terms. It's kind of like 6x plus 8x. Okay, that's 14x, not 14x squared. But I know where the problem stems from. Yeah, back in earlier mathhood, you probably saw something like this and thought, great. When I multiply, I'm allowed to multiply radicals as long as they're the same kind of radical, and I can multiply 3 times 2. I know, right? Totally different. So what's going to happen is we're going to have all this mix-up between these two. Hey, we're going to try and stop that today. So look at number 1. Notice, we can't subtract these. We can't subtract these because even though they're both square roots, they don't match. They have to have the same kind of radical, and they have to have the same number underneath. Or do they? Look, if I were to simplify the radical 27 and the radical 12, look what happens when I factor them. Oh my. Yes, I can go pair hunting with the square root. I get 9 radical 3 for the first radical, and 4 with a radical 3 left over. Oh, yes, now I can subtract them. 9 of these minus 4 of these is 5 of these. Yeah. Now I can handle that. I can handle that just fine. Let's do number 2. I'll help you factor just to save us time. We have a cube root of 54. Let's see, that's 2 times 27. 27 is 3 times 9, and 9 is 3 times 3. I did that very fast, but don't let that bother you. You can do it with time. We're just saving a little time right now. Oh boy, look what happened. Look what happened. I've got the cube root of a negative. Remember, cube roots of negatives are okay. I just have to bring that negative out. So I always just make it positive and make the number before it negative. Okay, or just put a negative out in front. So look what I have now. And 16 can be factored easily as well. Now they're going to simplify, but I'm going hunting by triples, groups of 3. I can bring a group of 3 out. That gives me 9 times the cube root of 2. Be careful with your index. Don't put it too high so it looks like 9 to the 3rd. 9 times the cube root of 2. This one, hey, we can't simplify that. We only have a single 2. We need 3 of them to bring it out. And, oh, 3 2's right there come out with that -7. That gives us -14, or you can say plus -14. Aha! Now we have like terms. 9 of these minus 2 of these is 7 of those. 7 of those minus 14 is a -7 of those cube roots. Yeah! And there we are. What do you think of that? Let's go now to number 4. Number 4 gives us a level of difficulty here. I'm a little worried about number 4 because right away I notice I've got a cube root of a negative, but then I have square roots. This looks totally bonkers, like I can't do anything. But I think I can. Let's see. Let's simplify first. We'll always try and simplify these bubbies first. I'm going to factor 28 on my factor tree. I'm going to take out this negative and factor 56 on my factor tree. And I'm going to factor 175. Let's see, that's 25 times 7. So, what's up with this? Well, we didn't simplify it all yet. Let's see what we end up with. Pair hunting in a square root gives me 20 radical 7. Okay, then I can subtract or add a negative here with this cube root. I can pull out a 2. Okay, and with a square root, I can pull out a 5. I get 25 out there, and the square root is 7. Now, before we get all whopper-jawed, look at how we only have 2 that truly match. The cube root is not a match to a square root. So I was thinking maybe we can just put the square roots together. If you have 20 of these and you take away 25 of those, you owe 5 of those. So we get -5 radical 7. The cube root just goes on the end. There's nothing we can do with that cube root. Okay? So that is our best answer. All right, so let's be careful with these. I know we can do these. Now with the exponents, with variables, I know this looks a little tough. Why don't we make it a little more reasonable, okay? So let's fix number 5. We're going to make number 5 a little more reasonable. Let's do this. It's going to be the square root of 27x to the 4th y. And we're going to be adding 4 times the square root of 3xy. Again, at first glance, we're stuck in the mud. There's nothing we can do. We can't add or subtract unless they're a perfect match. But when I simplify these things by factoring and trying to bring things out, whoops, I can't really simplify 3 times x times y. I need 2 3's or 2 x's or 2 y's. But I can simplify this first one. I can bring out a 3. I can bring out 2 x's. So I get 3 times x, boop, boop, boop. But I have a 3y under the radical. Oh, that's really nice. So as I look at this and I see that I have a single y, and I see over here that I have a 3x and a y, all of a sudden, I can't add these together. There's nothing to do. And that'll happen sometimes. Nothing we can do. Okay, now if you go down to the multiplication, remember, now it's a little more loosey-goosey. We don't have to worry about matchers except in the radical, because the square root of 27 has a square root like this 5, we can go ahead and multiply these. We could never add these. No way. But one thing you might want to do is throw them under the same radical. Yeah, they're equal to 27 times 5 under the radical. So let's go ahead and factor 27 and 5 and see what we can pull out. Aha! We can go pair hunting and we get 3 radical 15. Pretty nice, huh? Well, what do we do with number 8? Well, number 8 seems pretty reasonable because it has the same radical. But look what happens. The 3 times the negative 2. And I can take 10 times the 18. Now, I could write 180. But, you know, leaving it like this makes it easier to factor. See, the 10 is 2 times 5. And the 18 is 2 times 9. 9 is 3 times 3. Aha! So a positive times a negative is a negative. I can multiply the 3 and the negative 2. And now I can simplify. There's a pair. I can bring a 2 out. There's a pair. I can bring a 3 out. So now I'm going to get 2 times 3 times negative 6. That's negative 36. And I still have a single 5 under the square root radical. So I get negative 36 radical 5. Not too bad, huh? Well, why don't you stop the video and try number 9, because they're both cube roots. I think we can simplify a little bit. And remember, you're going to go triple hunting when you factor. Try number 9. Stop the video. All right, let's see how you did. Aha! The negative comes out to make this negative 5. Okay, and so now when we take 2 times negative 5, we get the negative 10. But our cube roots, 9 times 24, can be factored. And now look at everything comes out. There's nothing left. There's nothing left. 3 times 3 was 9. 3 times 8 was the 24. Look at this. I can bring out a 3 and a 2. Nothing is left. 3 times 2 times negative 10. Aha! Nothing remains under the radical. The answer is negative 60. I like that one. Okay? So take a pause now and see if you need to re-watch anything on this first page. Okay, now we're on page 2. We have some samples here of more multiplication, sometimes with variables. I don't think this is going to cause a lot of issues for us. I think you might find this a little bit nicer than our previous days here. Let's see what we got here. We're multiplying, but we have square roots. So if I were going to do this, I'd leave the 5 outside. But under the radical, I have both radicals that can be multiplied as to what's under them. So I can factor this out if I want to. 6 times 8, 2 times 3 is the 6. 8 is 2 times 2 times 2. And I have 9 for my exponent on the variable x. So let's see what I can simplify here. Let's see, do I have a pair of anything? I'm going pair hunting. I have a pair of 2's. Okay, I have another pair of 2's. How many pairs are in 9x's? How many groups of 2? Well, there'll be 4 of them. X times X times X times X. 4 pairs, and that'll leave 1 X left over. See, 8 X's, 4 pairs were brought out. So now my answer is 2 times 2 times 5. I have x to the fourth on the outside. And under my square root, I have a 3 and I have a single x. Done. How are we doing with that? Pretty good? All right, let's have you stop the video and do number 12, but remember you're looking for triples when we factor everything. Triples. Okay, so I'll get you started and let's see what you can come up with. Let's see, 54 is 2 times 27, 3 times 9, which is 3 times 3. I also have a 5, but with my m variable, adding exponents gives me m to the 12th. Stop the video and go triple hunting. Let's see what you get. All right, I went triple hunting. I brought out a 3. That left me with a 10 under the cube root. Okay, but how many groups of 3 will you get from 12? Well, that's going to give me 4 groups of 3. And there'll be no m variables left. So I get 3m to the fourth times the cube root of 10. Not bad at all. Yeah, I think you're catching on fine to this, I would imagine. Why don't we try some binomials? They're not bad at all. This might happen to us. And all these things come up when we're solving equations. That's why we need to be prepared for them. So as you look at this, we have 2 terms that can't be subtracted. Radical 5 doesn't match radical 2. We can't do this. But we can use a little distributive property. There's nothing outside of here, but this 5 will remain when we multiply these. What is radical 10 times radical 5? Well, that's radical 50. Then a subtraction. Again, there's nothing out here, so we have this negative 2. And radical 10 times radical 2 is radical 20. This might be our final answer. I don't know. Is it? Well, let's factor the radical 50 in a factor tree. Okay, as we try to factor these things, I know I'm writing them quickly, but that's because I have confidence that you can factor in a factor tree off to the side. Pair hunting. Bring out another 5. I'm left with 25 radical 2. Bring out a 2. I'm left with 2 times 2 and a radical 5. Can I do anything with that? Can I subtract anything? The answer is no, they don't match. This is my final answer. Let's look at number 16. It's a double distributive. 8 times 3. 8 times negative 1 radical 10. That's a negative 8 radical 10. In the inside now, negative 10 times 3 is a negative 3 radical 10. And a negative radical 10 and a negative radical 10 is a positive radical 100. Okay, so even though we can multiply what's under the radical, remember that when it comes to subtracting and adding, we need a perfect match. I think we have a perfect match. Those are like terms. And I know that the square root of 100 is really 10. So I can take this 24 and this positive 10 and make 34. And I can put my like terms together, and I owe 11 radical 10. Okay, now as you look at this, we really like to have it in this order. We like the regular whole number, integer, and then we follow with any radicals. Okay, now the one that might trick us a little bit is number 18. In number 18, You might be tempted just to square these two terms. I know it's happened even on our midterm, it was happening. But we've got to fix that. This means two of these groupings being multiplied. So this is the FOIL, the double distributive. 4 times 4. 4 times negative radical 5. Well, they can't really go together except as 4 times radical 5. Let me fix that. I had a little goof. All right, the insides. The insides, 4 times negative radical 5. Well, that's a negative with a radical 5. And finally, a negative times a negative radical 5 will give us a positive radical 25. Now, some of you might notice that right away. It's just 5. That's great. So now we're going to take 16 and this positive 5, not 16 minus. This is like a negative that goes with this term. 16 plus 5, and put the two like terms together, and we owe 8 of those. Done! So that is your video for the day. Let's get a little practice done. Here's our practice page. Let's work this the best that we can, all right? I'll show you the answer key, but I want you to work this the best you can. I know it's Friday, but let's make it work. Give it a good try.